Hello everyone, this is Aston Francis. In this presentation, I show a two-party hotline. This is automation case study 5. I invented a two-party hotline system in around 1984 while working at the Jamaica Public Service. This was essentially an intercom that used two standard telephone instruments. This was used for communication between a manager's office and the contractor's office located at the JPS head office in New Kingston. Here is some background information. I immigrated from Jamaica to the US in 1993. This was my graduation ceremony in early 1982 at the College of Arts, Science and Technology. I had just completed my City and Guilds training course, 5th year. My disclaimer: I do not claim that this two-party hotline met industry standards. It was temporary and built from locally available parts. It was isolated from the JPS commercial systems. My training and expertise are in these fields of engineering: industrial controls, SCADA, telecommunications, computer hardware, software, cybersecurity, database, etc. The manager that worked with the contractors at the JPS head office did not want to give the contractors a dedicated phone line. It may have been for security reasons or cost or both. I was approached at the ECS department on Washington Boulevard in around 1984 to build an intercom so that the manager can communicate with the contractor in the contractor's office outside. The contractor's office was detached from the main head office, as shown in the next slide. Here is an aerial view of the JPS head office in New Kingston, and there is the contractor's office on the left. And the cabling, if I remember correctly, was around 250 feet, and that was downstairs. So the manager would have to take the elevator downstairs, walk across the yard over to the contractor's office. So if he had to do this several times, you see the need for an intercom or a dedicated phone line. This two-party hotline system was designed to work like a plain, ordinary telephone system called POTS. It used two standard telephone instruments, negative 48 volt DC and 90 volts AC at 20 Hertz for the ring voltage. There were no special bells, buzzers, or switches, just standard telephone instruments. And this intercom was more of a band-aid or a temporary solution. This is the blueprint that was created from the schematics I drew up manually by hand. I had sent this to the drawing office to have them formally create a blueprint. So I think that is why there's a discrepancy between the date. So it was around early 84 that this was designed and installed, but the drawing date shows 1986. I architected the solution, designed the schematics, built the circuit board by hand, and did the entire assembly 100%. Here is the redrawn schematics for the two-party hotline. If you notice, at the bottom left is a 555 timer That's for the ring cycle. It turns on about 2 seconds, turns off about 3 seconds. And these use the CMOS logic gates, 2 optocouplers or opto-isolators, 2 electromechanical relays, and plain old ordinary telephone system POTS uses negative battery. That is why negative 48 volts is at the top on the right. So that's a linear voltage regulator that produces negative 48 volts, negative 24, and minus 9 for the logic circuits. Here is how the system works. On the left is subscriber 1. On the right is subscriber 2. Both telephones are on hook. So this is the normal state. Subscriber 1 goes off hook or loops the line. OC1 will activate and gate 1A input will go low. Logic gate 1C output will go logic low. This will be connected to transistor Q2, which operates relay B. So at the top, B relay B1, B2 contacts will switch to the ring generator and the phone will ring. When subscriber number 2 picks up the phone, it will operate OC2 optocoupler and logic gate 1B input will be low. That propagates through to the flip-flop and the output of that flip-flop will go high and turn off relay Q3. So the ring relay will release and the talk path between subscriber 1 and 2 will be connected, since both of those two relays A and B are in their normal release state. So that trips the ring. After both parties are finished talking and they hang up the phone, the logic states will be as shown. Notice that there is no dial tone and there is no ringtone. This is exactly how I was trained in 1981 when I went to Boonton, New Jersey at the company called RFL Industries. They sold the JPS, the telephony systems called the selective part line. And the instructor, he went through the schematics in detail, showing us how each logic gate operates, how each transistor operates, so that we can repair, maintain the system down to component level when we get back to Jamaica. Here are 3 examples of doing a logic function with different technologies. The first one on the left, you're performing a logical AND function using logic relays. If D1 is operated and CD4 is closed and something else, then E relay will operate. That is a logic function. In the middle, those are actual hardware logic NAND gates, similar function but inverted. On the right is the software equivalent of an AND logic. I have attached several slides to show my history, training, and education, and work experience. I also built a multi-line telephone interface for the Hunts Bay Power Station B6 control room. This was made using CMOS and similar technologies as shown before. This was done in around 1982, and this worked at the power station for several years. I created this manual for the multi-line telephone interface, and I created 2 large full-size blueprints. I do not have these blueprints. They're probably there at the drawing office in their permanent records. Here is an example of a Strowger 2000 type final selector. This was what I worked on at the telephone company between November 77 and November 1980 in Jamaica. This schematic is either exact or close to exact schematics that was used in the telephone exchanges. These are the actual textbooks that I used in college between 77 and 81. I stacked them up on the counter and took a picture. I bought this calculator in around 1978. It was supposed to be the latest and greatest calculator money could buy, and it was programmable. There was a group of us from the Caribbean that went to the U.S. Virgin Islands for training, which was provided by the United States Telecommunications Training Institute. The companies that trained us were Motorola, AT&T, and Western Union. This is Aston Francis, and thanks for watching.